Hello. In this problem we will see a conditional probability problem where we will use a tree diagram. Let's see what the problem says and break it down. Jenny goes to school by bus every day. When it is not raining, the probability that the bus is late is 3/20. When it is raining, the probability that the bus will be late is 7/20. Now, the probability that it rains on a particular day is 9/20, and the question is here. On one particular day, the bus is late. Find the probability that it is not raining that day. Now, in this problem here, obviously, I have two incidents, rain and the bus being late. So from that, I can understand that I will have a tree diagram where I have two events. Now, the initial event will be, of course, raining. So if I will make a tree, one branch will be raining and the other branch will be not raining. Now what happens if it rains or if it not rains? The bus, there is a probability that it will be late or not late. Also, for if it will not rain, the same, it will be late or not late. Now I'm coming back to the problem and we'll fill in the probabilities. Now, when it is not raining, so I'm in this branch of the tree, the probability that the bus is late is 3/20. So when it is not raining, the probability is 3/20 to be late. Obviously, since when it's not raining, the probability to be late is 3/20 to be late. So the probability not to be late, it's going to be, what is remaining? 17/20. I continue. When it is raining, the probability that the bus will be late, so I care about this branch, is 7/20. So since it's 7/20 when it's late, for not being late, it's going to be 13/20, because both of them, they should have 1 as a total probability. Now, the probability that it rains on a particular day is 9/20. So to rain is 9/20. So not to rain is going to be the rest, 11/20. Now, let us break down how much is these probabilities. Now, to calculate this branch here, so the probability of raining and being late, the probability of rain and being late is 9/20 times 7/20, which is 63/20. Sorry, 400. Here on this branch, it's the probability of raining and not being late, which is 9/20 times 13/20, which is 117/400. Here, the probability of not raining and being late is 11/20 times 3/20, which is 33/400. And the last, the probability of not raining and not being late is going to be 11/20 times 17 over 20, which is, let me make the calculation, 17 times 11, 187 over 400. Now, we will come to the problem. Here is what we have to decode. It says, on one particular day, the bus is late. So they give me as a fact that the bus is late. Find the probability that it's not raining that day. Now, if I will express that as a probability, it means the probability that, given that the bus is late, it's a conditional probability, given that the bus is late, I want to calculate the probability that it is not raining. Now, as we know, the probability, the conditional probability of an event A given B is the probability of the intersection of the two events over the probability of the given event. So if I'll take that, I need the probability of not rain and being late over the probability of being late. Be careful here. This is the only crucial point here. The probability of not raining and being late, I have calculated, and it is here. You can see it. Not rain and being late. It is here. So this probability is being given. It is how much? 33 over 400 over. Now the probability of being late, I have two branches that they give me the probability of being late. This branch of being late, which is this probability, and this branch also of being late, which is again this probability. So the probability of being late is the probability not rain and being late, which is 63 over 400, plus not rain and be late, which is 33 over 400. And now if I'll simplify it here, it's 33 over 400 divided by 99 over 400, which is, if I'll simplify my composite fraction, 33 times 400 divided by 99 times 400, which is 1 over 3.